On March 19, 1912, a brutal 9-day blizzard stranded Robert Falcon Scott, Edward Wilson, and Henry Bowers in their tent, just 11 miles short of a supply depot on the Ross Ice Shelf. The trio was nearing the end of their return journey from the South Pole. In her book, The Coldest March, Dr. Susan Solomon described this tragedy as follows. Wilson and Bowers met their deaths with the injured Scott, but the scientific constraints of modern meteorology as shown here suggest that their deaths may have been a matter of choice rather than chance. Whether such a choice was made, and whether it reflected their own dedication or an order by a desperate Scott vainly trying to save legacies rather than lives is a question not for science but for the human heart. In this brief video, I will demonstrate that the scientific constraints of modern meteorology referenced by Solomon are entirely unfounded and, in fact, do not exist. I believe her conclusions stem from a fundamental misinterpretation of the atmospheric dynamics of the Ross Ice Shelf.
Because you're shielded so well from cyclones moving in from the coast.
The Ross Ice Shelf is not shielded from the cyclone, quite the opposite. Nearly every strong wind event, blizzard, at both Scott's Last Camp and the Corner Camp, influenced or driven by synoptic scale cyclones or mesocyclones.
The conditions on the barrier are pretty strongly katabatic.
The atmospheric conditions over the Ross Ice Shelf are not predominantly katabatic. The barrier wind, which channels along the Transantarctic Mountains, was first formally described by Dr. Werner Schwertfeger in 1984, nearly 20 years before Solomon's book was published. Barrier winds are a well-documented result of cyclonic activity. Nearly a decade before Solomon released her book, William P. O'Connor published a pivotal 1994 article titled Cyclonically Forced Barrier Winds Along the Transantarctic Mountains near Ross Island. His research offered early and influential evidence linking cyclones to the formation of barrier winds in the Antarctic. Since Schwertfeger's initial work, nearly every scientific study addressing the wind regime at the Ross Ice Shelf has acknowledged the role of barrier winds. Additionally, there are other notable wind regimes in the region, beyond just the katabatic and barrier types. The next wind regime shown here reflects conditions associated with the passage of synoptic scale or mesoscale cyclones. While barrier winds are also linked to these systems, they generally blow steadily from the south. In contrast, the depicted cyclone-driven winds can shift direction. For example, on this day in April 2011 at the site of Captain Scott's final camp, the wind was blowing from the north, a direction Captain Scott sometimes described in his journals as a relentless headwind. And here comes my favorite, the awe-inspiring katabatic winds, one of Earth's most powerful weather forces, as seen from space. But wait, how on earth can winds be seen from space? Well, though the winds themselves are unseen from space, their warm footprints trace across the terrain, betraying their silent, forceful flow. But what are katabatic winds, and why do they leave warm footprints? Think of katabatic winds as gravity's breath, cold, heavy air sliding down Antarctica's icy slopes like a ghostly waterfall. These winds begin high on the Antarctic plateau, where the surface ice chills the air to extreme lows. That air becomes so dense, it starts to sink. Gravity takes hold, pulling this frigid air down through the glacier-carved valleys of the Transantarctic Mountains, accelerating it into a powerful, invisible jet. And here's the twist, though the air begins icy cold, it warms as it descends, not from sunlight, but through adiabatic compression. As the air is squeezed by increasing pressure, its temperature rises. It's a quiet transformation, like a whisper turning into a roar. These katabatic winds carve warm streams across the frozen landscape, visible in infrared imagery as subtle, sinuous ribbons of heat. It's Earth's coldest breath, leaving behind a warm signature, a hidden current of motion and heat, written in the language of temperature and revealed only from above.
I could talk a lot more about the katabatic winds and how they work, but I just want to tell you that the pool of cold air that can form on top of the plateau has to be finite. There's just only so much cold air up there. So the longest blizzards that have been seen yet in this region lasted about 4 days.
Speaking of records, let me tell you about George Simpson, the Terra Nova expedition's meteorologist. He wasn't just observing the weather, he was making history with it. And here's what he wrote. The longest blizzard occurred in June 1912 when from 20 hours on the 7th until 11 hours on the 14th, i.e., for 6 days and 14 hours, the anemometer recorded more than 20 miles in every hour and the mean velocity during the period was 48 miles an hour. George Simpson described a nearly 7-day, clearly a barrier, not a katabatic, blizzard driven by deep synoptic cyclones. Which brings up a big question, when it comes to katabatic blizzards, is the pool of cold air really finite, like Solomon claimed? Or is there more to the story? You are now witnessing the relentless power of katabatic winds. These are 15 consecutive days of satellite images, captured between August 13 and August 28, 2004. The pool of cold air on the Antarctic plateau is not finite because it is constantly being topped up by the planet's biggest cold air factory. It looks like this dense, heavy air then gets so fed up with being at the top of the continent that it throws itself down the slopes, creating the world's most dramatic katabatic wind avalanches. It is an endless cycle of cold air being made, getting a bit too full of itself, and then tumbling downhill to escape. As you can see, katabatic winds can blow for days, yet not all of them penetrate deep into the Ross Ice Shelf. Many get trapped near the entrances of glacier valleys, unable to advance. That's because katabatic winds often need assistance to travel farther, and that help usually comes from larger atmospheric systems like synoptic cyclones or mesocyclones. Much like barrier winds, katabatic winds depend on these expansive weather systems to spread across the Ross Ice Shelf. And that brings us to what Solomon regarded as the most damning constraint of all, the one that, in her view, undermines the very heart of Scott's final account, the claim that the blizzard he described may never have happened at all.
And I think there's proof that that isn't quite what happened. Let me tell you how we know. So if you look at satellite images of winds flowing on the barrier, you can tell where the warm part is by this dark region. That's where the katabatic wind is flowing. The barrier is just this big flat ice shelf. So to a large extent, the wind can only follow the direction of the flow. There's nothing to break it up. In late March, 2 men sledged to Corner Camp. This was the last attempt to rescue Captain Scott. So they went out to the edge of the barrier and they waited. The conditions that they experienced there were very, very good. Balmy temperatures of -17, winds under 20 miles an hour. So definitely there was no blizzard on those days right here at Corner Camp. And if there had been a blizzard upstream here in the middle of the barrier, I find it hard to see how there could not have been one at Corner Camp.
So basically, Solomon's saying, if it was sunny at Corner Camp, then Scott's last camp wasn't getting blasted by a blizzard. And why is that? Because, get this, the winds on the Ross Ice Shelf are like stubborn toddlers on a one-way track. They only go in the direction of the flow, no detours, no surprises. It's like Mother Nature drew a line in the ice and said, follow this, or else. If Solomon's right and the winds at the Ross Ice Shelf are doomed to follow the flow like obedient icebound minions, then, why are scientists still poking at them like they expect a plot twist? Maybe because, in reality, Solomon's version of events reads more like a detective story than science. No, katabatic winds do not follow the general direction of the flow. Their behavior is influenced by several factors, for instance, pressure gradients associated with cyclonic systems. This isn't exactly groundbreaking information, people knew about it even before Solomon's book came out, thanks to scientific studies and satellite images. One particularly amusing detail is that a satellite image used by Solomon, featured both in her book and presentation, clearly shows a synoptic scale cyclone positioned on the left-hand side of the katabatic flow.
So by the end of March, as the men were finally dying, I don't think that what was keeping them in the tent was a blizzard. I think they were stopped by a blizzard on March 19th. I think it lasted 2 to 3 days. There might have been a second one that started up, so maybe there was a lull and then another one, and they didn't quite describe that. That's possible.
Well, now, Dr. Solomon seems surprised that the dying men failed to mention a second blizzard. The one that, inconveniently, likely never existed, because the first blizzard never eased up, not once, until they were gone. It's a curious expectation, isn't it? Hoping for meteorological footnotes from men who were freezing to death under an unrelenting storm. To truly comprehend the weather that engulfed a solitary tent sheltering 3 dying men, one must understand how an Antarctic blizzard unfolds, especially in the region around Scott's last camp. Here's another cool tidbit about the wind patterns around the Ross Ice Shelf. So, imagine this, the same cyclone that kicks up those intense barrier winds can also trigger katabatic winds, without even pausing for breath. All it takes is a little nudge southeast and a shift in direction, and boom, the whole wind system flips. That's likely what happened during Captain Scott's final blizzard. It wasn't just one type of wind, it had both barrier and katabatic winds swirling together, back to back, with no breaks in between. Watch closely once more. The first image, captured on April 5, 2017 at 6 o'clock Universal Time Coordinated, reveals the cyclone's orientation and location with telling clarity. At this moment, a barrier blizzard is active at both Scott's last camp and corner camp. Fast forward exactly 24 hours, April 6, 2017 at 6 o'clock Universal Time Coordinated, and the story shifts. The cyclone has drifted southeast and rotated in orientation, subtly reshaping the atmospheric dynamics. The blizzard at corner camp had already ceased some time earlier. Meanwhile, at Scott's last camp, the barrier blizzard didn't pause, it transitioned seamlessly into a katabatic flow.
Why does a blizzard happen? The main reason is because of the katabatic winds of Antarctica. On the high plateau, temperatures drop and very, very cold air pools. What can happen is that there's a front come through and it literally will push the cold air off the plateau. It comes roaring down those glaciers.
Wait, what?
A front come through and it literally will push the cold air off the plateau.
Actually, no. That's not how the Antarctic works. The interior plateau isn't some busy freeway for frontal systems, it's more of a stratospheric still life. If cold air moves, it's because gravity politely but relentlessly insists, not because some weather front shoved it aside. So thankfully, cold air doesn't wait for a push. It grabs its parka, says Sia, and slides downhill like it's late for a polar plunge. Solomon described what transpired in Scott's last camp during those final days of March 1912 as a question not for science but for the human heart. Yet the Ross Ice Shelf bears its own heart, a symbolic echo of the explorers who perished there. That heart speaks through the Ross Ice Shelf airstream itself, urging us to honor their story with scientific rigor rather than unfounded speculation or the artificial constraints imposed by modern meteorology. Interestingly, in her own way, Solomon has unknowingly admitted her mistake, without actually acknowledging it outright, when she said,
I didn't mean to imply that there's no place else on the continent where you could have blizzards longer than 4 days long. That's clearly not correct. There's plenty of places where you can have much longer blizzards because, as you say, you can have cyclones that can last longer than that.
Now that it's clear the Ross Ice Shelf isn't protected from cyclones, and that these cyclones are the primary drivers behind virtually every blizzard in the region of Scott's last camp, will Solomon finally concede she was wrong? After all, acknowledging her mistake would only enhance her credibility and benefit her personally as a scientist.